100 Facts about Advanced Angles. Basic Concepts and Definitions. 1. Angle. The measure of the space between two intersecting lines or rays that meet at a common point called the vertex. 2. Types of angles. Acute, less than 90 degrees. Obtuse, greater than 90 degrees. Right, 90 degrees. Straight, 180 degrees. Reflex, greater than 180 degrees. 3. Complementary angles. Two angles whose sum is 90 degrees. 4. Supplementary angles. Two angles whose sum is 180 degrees. 5. Vertical angles. Angles formed by the intersection of two lines. They are congruent. 6. Alternate interior angles. Angles formed when a transversal intersects two parallel lines. They are congruent. 7. Alternate exterior angles. Angles formed when a transversal intersects two parallel lines. They are congruent. 8. Corresponding angles. Angles formed when a transversal intersects two parallel lines. They are congruent. 9. Interior angles on the same side of the transversal. Angles formed when a transversal intersects two parallel lines. They are supplementary. 10. Exterior angles on the same side of the transversal. Angles formed when a transversal intersects two parallel lines. They are supplementary. Angle relationships and theorems. 11. Angle addition postulate. If point B lies between points A and C, then M angle ABC equals M angle AB plus M angle BC. 12. Angle subtraction postulate. If point B lies between points A and C, then M angle ABC equals M angle AC, M angle BC. 13. Triangle angle sum theorem. The sum of the measures of the angles of a triangle is 180 degrees. 14. Exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. 15. Parallel lines and transversals theorem. If two parallel lines are cut by a transversal, then the corresponding angles are congruent. 16. Converse of the parallel lines and transversals theorem. If two lines are cut by a transversal and the corresponding angles are congruent, then the lines are parallel. 17. Triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. 18. Pythagorean theorem. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. 19. Law of sines. In a triangle ABC, sin A equals sin B, B equals sin C, C. 20. Law of cosines. In a triangle ABC, C squared equals A squared plus B squared 2 ab cos C. Advanced angle concepts. 21. Angle bisector. A ray that divides an angle into two congruent angles. 22. Perpendicular lines. Two lines that intersect at a right angle. 23. Angle measures in polygons. The sum of the interior angles of a polygon with n sides is n2, 180 degrees. 24. Regular polygons. Polygons with all sides congruent and all angles congruent. 25. Angle measures in regular polygons. The measure of each interior angle of a regular polygon with n sides is n2, 180 degrees, n. 26. Angle measures in circles. The measure of a central angle is equal to the measure of its intercepted arc. 27. Inscribed angle theorem. The measure of an inscribed angle is half the measure of its intercepted arc. 28. Tangent lines to circles. A line that intersects a circle at exactly one point. 29. Angle relationships in circles. The angle between a tangent line and a radius drawn to the point of tangency is 90 degrees. 30. Angles in quadrilaterals. The sum of the interior angles of a quadrilateral is 360 degrees. Trigonometry and angles. 31. Trigonometric functions. Sine, cosine, tangent, cotangent, secant, and cosecant. 32. Trigonometric identities. Equations that are true for all values of the angle. 33. Trigonometric ratios. Relationships between the sides of a right triangle and its angles. 34. Inverse trigonometric functions. Functions that undo the trigonometric functions. 35. Trigonometric graphs. Graphs of the trigonometric functions. 36. Trigonometric equations. Equations involving trigonometric functions. 37. Applications of trigonometry. Solving triangles, finding heights and distances, and modeling periodic phenomena. Angles in real-world applications. 38. Architecture. Designing structures with specific angles for stability and aesthetics. 39. Engineering. Calculating angles for bridges, roads, and other infrastructure. 40. Navigation. Determining direction and position using angles. 41. Astronomy. Measuring angles between celestial objects. 42. Physics. Analyzing angles in projectile motion, optics, and mechanics. 43. Art and design. Creating visual compositions using angles and perspective. 44. Sports. Understanding angles in various sports, such as golf, basketball, and archery. 45. Computer graphics. Rendering images and animations using angles and perspective. 46. Robotics. Programming robots to move and manipulate objects using angles. Angles in geometry. 47. Angles in triangles. Acute, obtuse, and right triangles. 48. Angles in quadrilaterals, parallelograms, rectangles, squares, trapezoids, and rhombuses. 49. Angles in polygons, regular polygons, irregular polygons, and their interior and exterior angles. 50. Angles in circles, central angles, inscribed angles, and angles formed by tangents and secants. Angles in coordinate geometry. 51. Slope. The measure of the steepness of a line. 52. Angle of inclination. The angle between a line and the x-axis. 53. Angle between two lines. The angle formed by the intersection of two lines. 54. Distance formula. The formula for finding the distance between 2 points in the coordinate plane. 55. Midpoint formula. The formula for finding the midpoint of a line segment. Angles in calculus. 56. Limits. The behavior of a function as the input approaches a certain value. 57. Derivatives. The rate of change of a function. 58. Integrals. The area under a curve. 59. Trigonometric limits. Limits involving trigonometric functions. 60. Trigonometric derivatives. Derivatives of trigonometric functions. 61. Trigonometric integrals. Integrals involving trigonometric functions. Angles in number theory. 62. Modular arithmetic. Arithmetic with remainders. 63. Congruences. Relationships between numbers that have the same remainder when divided by a certain number. 64. Euler's theorem. A theorem about the powers of a number modulo a certain number. 65. Fermat's little theorem. A special case of Euler's theorem. Angles in combinatorics and graph theory. 66. Combinations. The number of ways to choose a certain number of objects from a larger set. 67. Permutations. The number of ways to arrange a set of objects. 68. Graphs. Mathematical structures representing connections between objects. 69. Eulerian paths and circuits. Paths and circuits that visit every edge of a graph exactly once. 70. Hamiltonian paths and circuits. Paths and circuits that visit every vertex of a graph exactly once. Angles in probability and statistics. 71. Conditional probability. The probability of an event given that another event has already occurred. 72. Bayes' theorem. A formula for calculating conditional probability. 73. Statistical inference. Drawing conclusions about a population based on a sample. 74. Hypothesis testing. Testing a claim about a population. 75. Regression analysis. Modeling the relationship between two or more variables. Angles in cryptography. 76. Public key cryptography. A type of cryptography that uses a pair of keys, a public key and a private key. 77. RSA cryptography. A widely used public key cryptosystem. 78. Elliptic curve cryptography. A type of public key cryptography that uses elliptic curves. 79. Digital signatures. Electronic signatures that can be used to verify the authenticity of a document. 80. Hash functions. Functions that convert data into a fixed-size string of characters. Angles in computer science. 81. Graphics programming. Creating images and animations using algorithms and data structures. 82. Game development. designing and implementing games using algorithms and data structures. 83. Artificial intelligence, developing intelligent systems that can learn and reason. 84. Machine learning, training algorithms to learn from data. 85. Data science, analyzing and extracting insights from data. Angles in physics. 86. Vectors, quantities that have both magnitude and direction. 87. Scalars, quantities that have only magnitude. 88. Velocity, the rate of change of displacement. 89. Acceleration, the rate of change of velocity. 90. Force, a push or pull on an object. 91. Torque, a rotational force. 92. Angles in physics, continued. 93. Momentum, the product of an object's mass and velocity. 94. Energy, the ability to do work. 95. Kinetic energy, the energy of motion. 96. Potential energy, the energy stored in an object due to its position or configuration. 97. Work, the transfer of energy from one object to another. 98. Power, the rate at which work is done. 99. Simple machines, machines that reduce the amount of force required to do work. 100. Levers, pulleys, inclined planes, examples of simple machines that involve angles. Note: